Hello everyone. Okay, I'm selling this combination of DC motor, Pittman DC motor, uh, encoder, and this housing would hold the rotary device uh, with timing belt, pulleys. This is a double pulley. Right now I cover with a black tape because I want to measure the RPM. The Pittman motor is 30.3 volts DC, and the encoder has a 512 counts per revolution, 4 wires. Unfortunately, I'm not able to test the encoder. It looks pretty straightforward. Just 4 wires, 512 counts per revolution. The Pittman motor is model number is 2236C185-R4 303101-002, 30.3 volts DC. The encoder is over here, right here. It's in like new conditions. I removed this from machined to change. It's a library data machine. It's very accurate. This could be great for many applications, including perhaps turn on a spindle, turn on axis, linear stage or linear guide, and it's in like new conditions. However, I want to sell used, and I'm not going to apply the 30 volts because I don't have right now a power supply for 30.3 volts, 30 volts. So however, what I'm going to use is a 24 volts DC power supply, and I want to measure the RPM, and from the measure that we found, we probably need to add another 300 to 400 revolutions per minute when we apply the complete voltage for the motor. So this is my digital tachometer. I want to turn on. Let me show you. It's running pretty good. So I want to try to make a reading. It's 1037 RPMs. So from there, if we apply the other 6 volts more, we probably get easy 1500 RPMs. It's very smooth, very nice rotation. This is the screws to help to increase or decrease the tension of the belt. The motor itself, this could be a good idea. The reductions, you see the large and the small one. So this Pittman, I'm pretty sure it's running about 4,000 to 5,000 RPM. But because the pulley is very small and this is very large, maybe by, I don't know, probably 5 times at least, I consider the motor itself is running for about 5,000 RPMs. Unfortunately, I can guarantee that, but you know, it's what I assume, because this is not a reduction. The motor is going very fast, and this large pulley make the reduction. So if you don't want to use this one, or if you want to use just the motor with your spindle, I want to include. I measured already. Let me turn it off. I'm going to remove the black tape that I put in there. I don't know if I'm able to check let me see if I'm able to do that. I don't think I'm gonna make it because I don't want to take apart, but let me see just by chance I can measure at least some of the RPMs in the motor. Oops, just blow away. I need to get actually, let me turn it off again. I'm gonna put the little reflecting stripe that I put in the black thing and see if let me measure the RPM in the motor. It's very hard because it's a tiny piece, the reflecting. Oh, it's not gonna let me. I want to try to measure the. Okay, I put a little piece now. Okay, however, I want to try to measure. When I put a little reflecting, I want to try to measure the RPM and the motor and let you know how much is the RPM in the motor. What I said, I'm pretty sure it's quite fast. Okay, so this is the entire housing, from the housing with all the bearings and the rod bearings in both ends to make these turns. So I will include in another extra belt that you can put in here, and then another smaller pulley, smaller than this one, probably by not by half, probably one a little bit of more than half. Perhaps we can get about 2000 RPMs in this configuration. But if you want to use just the motor in your spindle, this is a little bit smaller than this one, so I have a feeling you can get 6,000 to 7,000 RPM. What I said I can guarantee, but I want to try to measure the RPM in the motor. Okay, so the belt, the small pulley that you can put in pressure in your spindle. If you want to use as an axis, then you can use the nice timing and putting in another device, to acting as a axis. You need to, when you build, you have to put a clamp in here, so you're just going to travel back and forth perhaps 3 inches from one end to another end of when you apply the plate, a little support going to hold the axis. Well, it's many applications. Somebody you guys up there right now know what it could be the use for. This is the positive and negative of the motor. This is the 4 wires of the encoder. The belt is about, if I stretch the belt a little bit, trying to, is about 4.5 inches to 4.5 to 4.75 inches away from, so you have quite a room to whatever. And what I said, if you remove this one here, we are able to use the motor. And if you want to replace, this is very hard to replace because it's inserted by pressure in its factory set. Okay, the housing is made of cast iron. Very nice, very smooth, very accurate. It's a mountings in here in the bottom, and you have more holes to mount in the side, this side. So this is what you have. Only $34.99 excuse me, and $12 for shipping. I need to send it in a USPS medium flat rate box for $12. The box is $10.85, so because the weight is, you can get faster in USPS priority mail instead parcel post for almost the same amount. We take 9 days. So Thank you for watching. I will take some pictures and perhaps I make this just a second small video to see what is the revolution of the motor in a little bit. Thank you.